This is application of laws of motion. Application. So let's start on an incline. Let's say we have got an incline here. There is our incline. I need to make sure that this is so beautiful appearing. So this is our incline. Now an incline has got the angle of inclination. This is the angle there, theta. And say on this incline, we have got a box on top. That is our box. It has got a mass m. So first thing we want to understand all the forces that are acting on this box. You see, these things are easy. Just make sure you follow me properly. If you miss it, ask me while we are still there. We understand together, right? So here is our box. Looking at the forces acting on this box, the first force that you should know about anything, any object, is a force that goes downwards. What do we call the force that goes downwards? Excellent. That's the weight. And you know that weight is given by mass times gravity. Besides the weight force, you need to know a force that makes 90 degrees on the surface of a material. What do we call such a force? We've been talking about this now. The normal force. Excellent. So this is a normal force. Okay. Normal force doesn't have a specific formula. It depends with the situation. Now, when you have got an object that is on actually, if we make an extension of the normal force, we are going to have this. If you extend the normal force, and then you can get to connect this like this. So this dotted line that I'm drawing here is parallel to the incline. So it is from here that we understand something. The angle of inclination. So if I get this kind of small triangle that I formed here, this one going like so, I can put it now upright. So to make 90 degrees, 90 degrees I've made is this one, which is here. The hypotenuse is the weight times gravity. So this side that you can see, we can call it y. Okay, we'll put y there, and I can put y there, and then this side we can call it x. And then the angle of the incline, this angle here, is gonna be equal to this angle here. Okay, so this is what we need to know. So we are saying this angle on top is going to be theta. So from this guy, we want now to do some mathematics. If we say sine theta, sine is given by opposite over hypotenuse. So the opposite to theta is x. The hypotenuse is mg. This tells you that if I want to find x, x is going to be equal to mg sine theta. Please don't say no, x component is always equal to cos. This is not, these are not components. In that case, as we've been talking about in vectors, cos theta in this case is going to be, cos is adjacent of hypotenuse, the adjacent is y, the hypotenuse is mg. So meaning that y in this case is going to be mg cos theta. Are we okay so far? I'm taking it slow so that you understand this, because imagine you met a question in the exam which asked you to derive a certain equation. Is this okay? All right. So, all right, good. So for every object that is on an incline, you need to know that there's always a force that is pulling it downwards, down the incline. We call that as a force due to gravity, Fg. So in this case now, let me start working first in the y direction. The net forces in the y direction, you have got the upward force. That's a normal force. remove the downward force, that is y. Now this object is not jumping up and down on an incline. So therefore the net forces in the y is going to be equal to 0. So that will be 0 is equal to n minus, but remember the y is mg cos theta. So to make n, sub the formula, n is going to be equal to mg cos theta. So in this case, on an incline like this, the normal force is given by mg cos theta. That's the equation we need to know for an object like this. As long as the force that we are applying is not applied at an angle, the applied force, let's say we are pulling this object upwards or we are letting it to slide downwards, as long as we are not applying a force at an angle. Because if I apply a force at an angle on this object like that, what this would mean is that we have got now an applied force. This applied force is going to have components. It's going to have the component going downwards, Fy, to have the component going forward, which is Fx. So in this case, the normal force will change because the downward forces, we don't just have y, we are also going to have Fy. So that's what you need to take note. So in that case, when you want to calculate the normal force, also include the y component of the force that you applied at an angle. So let's deal with the forces that are given in the x direction then. We'll say the net force in the x is going to be, now for this one, we are not applying any force on this object. The only force that is making this object to move is the force that is going downward. So we'll just say Fg. Remember, net force is given by mass times acceleration. And Fg, you can see it's going downwards. It's actually parallel to x. According to the two vectors in mathematics, parallel lines which go in the same direction have equal magnitude and equal direction. So Fg is going to be equal to x. That is mg sin theta. So you can see that mass will cancel out. Acceleration therefore is going to be equal to g sin theta. What does this tell you? This tells you that when you have got an object that is on an incline and it is sliding, the acceleration at which it is going to be sliding does not depend on its mass, because you can see in this formula there is no mass. Instead, the acceleration depends on the angle of inclination. If the angle, if the incline becomes much steeper, the acceleration becomes much steeper. And the acceleration will also be different on Earth and on the moon because g is different. G on the moon is smaller than on Earth. Okay, so these are simple equations that I want you to understand at this point. Does this make sense? Is this okay? Okay. So let's do a simple practice question. Say you have got an object here that is on an incline, and here is our object. It has got a mass of 10 kg, and you are pushing it up an incline with a force of, say, 200 newtons. The angle of inclination is 30 degrees. Okay. And the height, for this object, for the incline, says 2 meters. Now let's say the incline has got friction. The coefficient of kinetic friction is, say, 0.1. This is mu k is 0.1. And then we've been told that the object starts from rest. Ob Now this, okay, so let me say object. Now we are going to take that it starts at the bottom, from the bottom. So the object starts from rest at the bottom. So what will be the number one? Find acceleration when it reaches the top. And then number 2, you also want to find the distance that it will travel for it to move from the bottom to the top. So I can label that distance as d. In physics, we don't use d for distance, we use s. Let me just put d. So find d. That d is the distance of the entire incline. Say part B of the question is find the final velocity v at the top of the incline. Okay, so these are the 3 questions that we have. First thing first, remember when you're dealing with anything, make sure you know the forces that are acting on the object. Now, this object is on an incline. Here is the object on an incline. The first force that you should ever think about acting on an incline is the weight force, which is mass times gravity. For any object that is on an incline, it is going to have a force pulling it downwards. That is Fg. And then I've got a force that is pushing this object forward. That is applied force. Now, because we have got mu k, that tells us that we have got friction. Friction is a force that acts against the motion. Because the force that I'm using, I'm pushing this object going upwards. Therefore, friction is going to be going downwards. So that would be kinetic friction. It would have been different if I was pushing this object downwards. Applied force would have been facing downwards. Fg would have been also facing downwards. But friction would have been facing this direction because friction will always be against motion. It doesn't matter which direction the motion is. In a case like this one, friction is going to be downwards. Why? Because the force that I'm applying is going upwards. Besides this, we also have the normal force going upwards like that. Okay. So therefore, let's start with the net forces in the x direction. The net forces in the x direction, let's start with the force that is taking us in the direction of motion. That is the applied force. Subtract the forces that are going in the opposite direction to the direction of motion. You have got Fk and you have got Fg. Net force is mass times acceleration. Applied force minus kinetic friction is given by coefficient of kinetic friction times normal force. Fg is given by mg sin theta. And then this becomes ma is equal to applied force minus coefficient of friction times normal force. Normal force in a case like this one, normal force is direct opposite to the force that is going downwards. That one is the one that we called y. We only have 2 forces going in the y direction. So normal force should be equal to y, and we know that y is mg cos theta. And then minus mg sin theta. So if I wanted to derive the equation for acceleration, I'll simply divide through by a. So the equation for acceleration would be applied force minus mu k mg cos theta minus mg sin theta over m. So because we have got applied force, mass is also going to affect acceleration. It's different from something that is just sliding without any applied force. And so therefore, for me to find the acceleration, I'm going to say applied force, that is a 200, mu k, that's 0.1, mass is a 10, g is 9.8, then we have got cosine of 30, minus mass again, that's a 10, g is 9.8, and then sine 30. Remember, we're dividing everything by the mass, which is a 10. The acceleration would be, we can punch that, 200 minus 0.1 multiplied by 10 multiplied by 9.8 cos 30, and then minus 10 multiplied by 9.8 sin 30, divide that by 10. So the acceleration is going to be 14.25 meters per second squared. So imagine after calculating the acceleration you found a negative number. That would mean that the force that we are applying isn't big enough to push the object upwards. Instead, the object is going to be moving downwards. Okay, so that's the acceleration. And then we want to find d. That's the distance from the bottom of the incline to the top. So d, you simply look at this. You have got the height of the incline, and then you have got the hypotenuse, which is d. And you know that sine theta is equal to opposite. The opposite of the incline is the height over hypotenuse is the same d. Therefore, when you are finding height, it is given by d sin theta. When you are finding the distance of the incline, is given by height divided by sine theta. And therefore, d would be, the height was 2 meters, sine 30. Sine of 30 is a half. So the distance would be 4 meters. And then the next question is saying find v at the top. Remember, the object started from rest. Want to find the velocity at the top. So you can simply say v squared is equal to u squared plus 2as. V squared, this guy started from rest, so that would be 0 squared plus 2. The acceleration we've determined 14.25. The distance covered on the incline, that is 4 meters. So this is v squared is equal to 14.25 times 2 times 4. That gives us 114.01. Square root both sides, and that will give us a velocity of 10.68 meters per second. Does that make sense? All right. Is there anyone that is left out? Anyone that is left out? Okay. Let's go to pass to tutorial sheet questions now. We see what we can do. When a force of 450 newtons pushes on a 20 kg box as shown, the acceleration of the box up the incline is 0.70. Find the coefficient of sliding friction between the box and the incline. The answer is here. So we need to confirm that. So first thing first, understand the forces acting on this object. You are going to have a downward force. That's a weight. And then we have got a force of 450 that is applied. Look at the way it is applied. It's not applied like this. It has been applied at an angle. And if you can actually see, can you see that the force is parallel to this axis? Okay. And you know from your mathematics in primary, is that grade 12? When you have got something that goes like this angle is equal to this angle. So the meaning of this is that the force that we are applying, so this is our incline, this is the object, and here is the horizontal. We are applying a force like this, and then we have got this angle like that. So the angle here is going to be equal to the angle there. And the force that we are applying, we can break it in two components. We are going to have the y component of that force, Fy, and then we are going to have the x component of that force. Because I'm pushing this object upwards, there's going to be a force that will be going downwards on the object. Remember, that's known as Fg. Fg always pulls object down the incline. Since we've been taught to calculate the coefficient of sliding friction or kinetic friction, it means that we also have friction, and friction always occurs in the opposite direction to the direction of motion. So we're going to have kinetic friction, sliding friction. Sliding is moving, kinetic. Okay. And then we have got the weight force going downwards, mg. We have got the normal force, which is there. And then we have got a force which we call y going downwards. So let's start with the forces in the y. The forces in the y direction, we have got the upward force as the normal force. Downward forces, please, mg is not a downward force. If we say down, we mean this direction on an incline, not this direction. You can see that mg is going straight down, but y in this case we take the diagonal. Okay, like normal force is upwards, y is downwards. The other force that is going downwards is fy. Can you see fy, which is the y component of the applied force? Have I lost anyone? This object isn't jumping up and down on the incline, so net force, remember, is given by mass acceleration. So the acceleration is going to be 0 in the y because this object is not moving in the y. So 0 is equal to n. But remember, how do you find y? Y is given by mg cos theta. And how do we find fy? Fy is given by y component of a force is given by force sin theta. Y, this is y component, the same one we use for vectors. Y component is always sin. And then that will mean that the normal force will take mg cos theta the other side and f sin theta the other side. So normal force will be equal to mg cos theta plus f sin theta. So you can see in this case, the formula for normal force changes. Normal force behaves like that. It's a chameleon. In Christianity, we say hypocrite. If I'm in Zambia, if I'm in Lusaka, I'm a Christian. Go on the copper belt, they don't know me as a Christian. So now we go in the x direction. The net force in the x is going to be equal to, okay, so the net force in the x is going to be equal to, look at the force that is going in the direction of motion. So because we are pushing forward, so the force that is going in the direction of motion is going to be the x component of the applied force. The forces that are going downwards, we have got Fg and then we have got Fk. Net force in the x is given by mass times acceleration. Fx component of the force is given by F cos theta. Remember, x component is always cos. Fg is given by mg sin theta, isn't it? We already derived out to find that. Fk is given by, remember, kinetic friction is always given by coefficient of kinetic friction times normal force. So that will be mu k. But the normal force, remember, the normal force is mg cos theta plus f sin theta. So therefore, if we wanted to derive an equation for acceleration, just divide everything by mass. Therefore, acceleration. So the question here is not even asking us about acceleration because we've already been given the acceleration. We want to find the coefficient of friction. Therefore, we're going to substitute where there is mass. The mass, the box is 20 kg. We were told that the acceleration of the box up the incline is 0.70. Applied force is 450. Cos the angle is 45. Minus mass again, that is 20. G is 9.8. Then we have got sine of 45. And then minus, we want mu k times mass is 20. G is 9.8. We have got cosine of the angle, which is 45, plus the applied force is 450. And then we have got sine of the angle, which is 45. We can start punching. We have got 20 times 0.7 at the beginning. That gives me a 14. That is equal to, we have got 450 cos 45 minus 20 multiplied by 9.8 sin 45. So those altogether have given me 179.605.6051225. Please never be quick to round off. Okay. And then we have remained minus mu k. I'm going to punch now what is in the brackets. 20 multiplied by 9.8 multiplied by cos 45, and then plus 450 multiplied by sine 45, and that has given me 456.79098. What I'll do at this point is I'm going to get this, take it to the other side of the equation. So that gives me mu k 456.79098, and that would be equal to 179.6051225. I'll take 14 the other side, so minus 14. So what I'll simply do here is I'm going to get mu k, make it sub the formula, so I'll divide both sides by 456.790. So what I'm doing is I'm getting 179.6051225 minus 14. You know, when I'm teaching these ones and I'm punching, you can also be following through punching so that to be easy. Divide that by 456. So the answer that I found is 0.362540. I can end here. This is the coefficient of friction. Let's see the answer given. You can see the answer given there, 0.3625, 0.363. So if you round off, you get a 1 from the 5. Have I lost out anyone? Have I lost anyone? Yes, please. So weight has got components. Weight is actually not going to be considered as a direct y direction. So in this case, as we said, we are taking the Cartesian plane to be like this. The x-axis is this, the y-axis is this. So a force that is going like this is not going to be in any axis. So you find the components. So the components of the weight is what is giving us the force that is going like that, we are calling as y, and the force that was going like this, which we are calling as x, which was equivalent to Fg. All right. Shalom, I saw your hand also. So the net forces for y are equal to 0, because if you look at this object on an incline, we are only moving it up and down the incline. It's not moving like this, like it's not jumping from the incline. So if it was moving up down on the incline, we would have said net force is mass times acceleration, but it's not moving, it's not jumping from there, it's only moving in this direction. So that's why net force in the y is 0. Okay, good. Is there another question? Okay, we have got this question here. The two boxes have identical masses, 45 kg. Both experience a sliding friction force with coefficient of friction being 0.15. Find the tension in the cord and the acceleration of the boxes. So because one object is on an incline, these objects are going to be pulled in this direction. Even this one will be pulled in that same direction. So let's start with object A, which is on top of the incline. We look at the net forces acting on that object. and those are going to be forces in the x. The force that is pulling it in the direction of motion is the force that is present in the cable because of the pull by object B. And we call such a force in a cable as tension. We've been told that both objects are subject to friction with a coefficient of friction of 0.15. So we are going to remove the friction force, which is behind. And net force in this case will be mass times acceleration. So object A is moving like that, mass times acceleration, and that will be equal to tension. Coefficient kinetic friction is given by coefficient of kinetic friction times normal force. For this object, since it's on a level ground, the normal force is equal to mg, which mg is downward. So we'll say mg here where there was normal force. If I put mass, we've been told that this object have got the same mass of 45. So put 45 there times acceleration. That will be equal to t minus mu k is 0.15. The mass again 45. G is 9.8. So I'll make t subject the formula. So t is going to be equal to 45a. I'll take this term the other side, but let me first multiply 0.15 times 45 times 9.8. That is going to give us a positive. Remember, I've gotten this term and taken it the other side of the equation, positive 66.15. This is equation 1. To find the equation 2, and so for the unknowns, we'll now use the object that is on the incline. For the object that is on the incline, there is no applied force. The only force that is pulling it downwards is Fg, the force due to gravity on an incline. But we've been told that both experience a friction force of mu k. So even on object B, you have got a friction that is acting in the opposite direction. That is kinetic friction. But besides kinetic friction, you also have the friction that is in this code that it is using to pull the other object. That's the tension. So I've got two forces that are acting in the opposite direction for object B. Therefore, we'll say the net force for object B in the X, the force taking it in the direction of motion is Fg. Opposing forces, we have got tension and we have got kinetic friction. Net force is mass times acceleration. Fg is given by mg sin theta minus tension. Fk is given by a coefficient of friction times normal force. Remember, normal force on an incline, as long as there is you are not applying any force at an angle, is given by mg sin cos theta. Okay, the first equation that we used, because you only have y and normal force here. So normal force is going to be equal to y, and y is equal to mg cos theta when it comes to an incline like this one. So these are the forces acting on this object. And then we can now be substituting the values. Mass is 45 times acceleration, that will be equal to mass again 45 times 9.8 times sine of the angle is 30, minus tension minus mu is 0.15, mass again is a 45, G is 9.8, and then we have got cosine of 30. So we are going to have 45a is equal to, we can punch 45 multiplied by 9.8 multiplied by sin 30. That gives us to 0.5, and then we have got minus t minus, we have got 0.15, which is mu k, multiplied by 45, which is the mass, multiplied by 9.8, which is g, multiplied by cos 30. That has given me 57.28758. So we are adding this and this because they are like terms. So 220 minus 57. So 220.5 minus the 57. And then what I'll do is that I'm going to get this guy, take it the other side of the equation, it becomes positive, right? And then 220 minus 57 gave me a positive 163.2124195. And then I'll take this 45a, take it the other side, it becomes negative 45a. This is equation 2. So we have got two equations. Now we can equate them. We have got 45a plus 66.15. This is going to be equal to the other equation 163.2124195 minus 45a. I'll take the 45a this side. 45 plus 45, that's a 90a. That will be equal to the other one that has remained. 166 will take it the other side, so we're going to have 163.2 minus 66.15, and that is going to be a 97.0624. Remain with a, divide both sides by a 90, and this has given me 1.078471328. This is in meters per second squared. So you can see that's the acceleration, the 1.078. To find the tension, you can use any one of the two equations. We can pick this one here. Tension is equal to 45 multiplied by acceleration 1.078, and then plus 66.15. The tension is going to be this 1.078 times 45, and then my plus 66.15, that has given me 114.68. Tension is force, this is newtons, so that's 114. Let's confirm 114.68, so we can confirm that. Does this question make sense? Are we okay? What does it mean if people are quiet? Is it fine, or people are too confused to even ask anyway? Okay, we can do the last practice here. A block takes twice as long to slide down an inclined plane that makes an angle of 35 with the horizontal as it does to fall freely through the same vertical distance h. What is the coefficient of kinetic friction? So they are saying the block takes it twice as long to drop. So the time it takes to slide here is 2 times the times it takes to drop. So if it takes t to drop, it will take 2t to slide downwards. Okay. So you are just doing some good mathematics. So let's start. The question is, what is the coefficient of kinetic friction? Look at the forces acting on this object. Nothing has been given, so there is a force of which we know is Fg. Because they've asked us to find the coefficient of friction, it means that we have got a friction that will be opposing it, and that will be kinetic friction. Therefore, the net force in the x is going to be, the force pulling it in the direction of motion is Fg. The force opposing motion is Fk. So this will be mass times acceleration is equal to Fg is given by mg. This is sin theta. And then minus Fk is given by coefficient of kinetic friction times normal force. For normal force on an incline, it's mg cos theta. You can see mass will simply cancel out. So what we're dealing with here, that's why for the question they've not even given the mass, because our operation doesn't need the mass. So we see that acceleration is going to be g sin theta minus mu k g cos theta. Let's substitute what we have. L is going to be equal to g is 9.8. We have got sine of the angle is 35. minus mu k, g is 9.8, and then cosine of 35. So a is going to be 9.8 multiplied by sine 35. That is going to be a 5.621049. And then minus, we are going to have 9.8 cos 35. That has given me, so I've got, of course, mu k times 8.02769. We have got two unknowns, so we can't solve this. But we know that the time it takes the block to drop is at the same time it takes this to fall down the incline is twice the time it takes for the block to drop down. Okay. So since we are talking about acceleration, we want to find an equation that has got time in it, and then we put where there is acceleration. Which equations do we know for that? We have got three equations of motion. Acceleration is equal to v. Let me start properly, not like this. We have got v is equal to u plus at, and then we have got 2as is equal to v squared minus u squared, and then we also have s is equal to ut plus half at squared. So we want an equation that has got time in it and acceleration. Okay. Another thing, of course, that we know from the incline is the distance. We've even been given the distance x. But when it comes to velocities, we don't know the final velocity. So we want to avoid the equation that has got final velocity in it. So we can use equation 3. Distance is equal to ut plus half at squared. If we start on the incline, like here, going downwards, the distance there is x. So we're going to say that x is equal to u. So we are going to take that this block starts from rest on the top there. So where there is u, put 0 times t. And then we're going to have half. A is the acceleration. So put a there. And then t is the time. Remember, the time it takes for the block to fall downwards is twice the height. So we're going to put 2t there. I mean, it's twice the time it takes for this to drop here. And this is squared. So therefore, x is going to be equal to half the acceleration, 2 squared, that will be 4. 4 times this half, it's a 2. So simply say x is equal to 2a t squared. This is the first equation. Is this okay? I have not confused anyone. Hope so. And then we'll come to the height. We've been told with the horizontal as it does to fall freely through the same vertical distance h. So when it is falling, it is going to take t. So falling again, I'm still going to use the same equation. S is equal to, but s, we are using height there. And it's still falling freely, so meaning starting from rest. U is 0. So we're going to have half. But when something is falling freely, acceleration becomes acceleration due to gravity, which is 9.8. And remember, the time falling down is only the t, so that will be t squared. So here we are going to have height is equal to half into 9.8, or times 9.8, or 2 into 9.8. That's 4. What's that? 9.8 divided by 2, 4.9. We have got t squared. I want this to be x, this also to be x. We know the relationship. When you are on an incline, sine theta, sine is given by hypotenuse, which is the height over, sorry, hypotenuse, opposite is the height over hypotenuse. The hypotenuse is x. So height is actually equal to x sin theta. So where there is height here, we'll put x sin theta. That is x sin theta is 35, and that will be equal to 4.9 t squared. So sin 35 is a 0.5. So I want just remain with x. So I'll divide both sides by that 0.57. So over the other side we have got 4.9. We'll divide that by 0.57. That is going to give us 8.542889 with a t squared. This is equation 2. Now we can solve these two equations simultaneously. Equation 1 and equation 2. So we are going to have, where the equation 1 we have got t 2a t squared. This is going to be equal to equation 2. We have got 8.54288.9 t squared. Can you see that t squared is going to cancel out? That remains with 2a is equal to that. So to remain with the acceleration is going to be 8.54 divided by 2. And that is going to give us a 4.2714444649. And then we'll come here and substitute where there's acceleration at that point, because the question is asking us to find the coefficient of friction. So we'll say 4.271444 is equal to 5.621049 minus mu k 8.02769. What I'm going to do is I'll take this term the other side, so it will be 4.27 minus 5.621049. So that will give us negative 1.3496, and that will be equal to negative mu k 8.02769. To remain with mu k, I'll divide both sides by negative 8.02769. So that has given me mu k being 0.168. Let's confirm that, 0.168. So you can see that's the one there. So that is how you get to work out these questions.